Good afternoon, everyone, and we will start with our new session, which is on wind energy, and it says propelling wind energy, repowering old wind turbines, change in the bidding mechanisms, and charting the roadmap for offshore wind farms. So, a very longish title, which shows that the wind energy is becoming more and more complex and is getting linked up with many other things which are not necessarily only wind energy. And in the past, we used to talk about, how many installations we can get with wind energy, where are the manufacturing capacities and things like that, which is very much there. But now we have to talk about many more things. And as you saw in the previous session, they were already talking about wind energy. This was a session on hydrogen, and they started talking about wind energy. And one gentleman, he mentioned that maybe we are not getting enough wind energy in India because we have less sites or something like that. So let me just set this point straight that whatever renewable energy we have in India, a major part of this renewable energy has come out of wind. And when there was no solar, when there was nothing else, only wind power projects were being set up in the 80s, 90s, and till now. It is only in the recent past, I would say only 2010 onwards, that solar picked up because of the cost reduction. And so now we are increasingly talking about not just wind, not just solar, we are talking about hybrid projects, so solar and wind. And there is a hybrid policy from the government of India which says how you can do a hybrid project, and one can discuss those policy issues, that is a different thing. Then there is a repowering policy. So we are not only talking about new wind turbines, we are talking about whatever wind turbines we have set up. Now what do we do with them? How do we repower them? How do we get new manufacturing, new wind turbines into that? And then there is a lot of talk about round the clock power, that the stakeholders, they are demanding that we want firm power. So we want power all around 24 hours. The wind doesn't blow all around 24 hours. So we have to get solar, we have to get battery, we have to get pumped hydro, we have to combine these things. And after combining everything together, we can say, okay, now we bundle it all together and we can give you 24 hours supply. Or somebody says, I want only peak power. So I want power between 9 and 12 and 6 and 10, and give me power, and what will you charge? So then you have to work it out again and say, okay, this is how we will do it. And now the new things are coming up like hydrogen. And this is only being talked about at the moment, but of course the potential is very huge. Hydrogen can potentially be used to convey renewable energy into transportation, even into cooking and industry and furnaces, all kinds of energy requirements. So what we see is that through hydrogen and through battery storage, we are able to take this renewable power which may be generated from some site in a remote place in Kutch or in Tamil Nadu to power your vehicle, the electric vehicle on the road, EV, or to maybe provide gas kind of fuel for cooking or something. This could be in future. So the demand is huge, and the topic itself is propelling wind. So we have to see how we propel this wind for the benefit of the country and benefit of the energy industry. I have with me gentlemen who are, well, in some way they are all CEOs, they are in CEO capacity. And for example, Balram, he represents nearly 9 gigawatt of renewable energy that has been set up by Renew Power. And we have Limaye, he looks after the wind turbine blade industry. So the LM glass fiber, he looks after the blades, and he's also in that kind of a capacity. Mr. R.P.V. Prasad, he is from Envision, relatively new company in wind energy, but they have in recent times got very good order books. So they are also on a gigawatt scale. So I will call them all the gigawatt CEOs. And to begin with, I have just one question to each of them. And since they are very deeply into technology, into manufacturing, into projects, I will begin with Prasad. What do you think we will have as wind power capacity in 2040? I'm talking about 20 years ahead because 10 years is a very short period of time in which, maybe offshore may not take off so well or something. So what do you think we will have as installed capacity by 2040?
Thanks, Hello. Hello. Is it okay? Audible? Yes. Yeah. Thanks a lot. And good evening to everyone. Thanks to Blue Circle for inviting me, and a pleasure to sharing with the eminent speakers, Mr. Jami and Balram and Hemkant. Just before going to the question, this one, I want to give you a few statistics, what is available in public domain. See, at present, total generation capacity in India, including fossil fuel and renewables and all together, 411 gigawatts already there, 400 gigawatts, out of which you can say renewables both fossil fuel is 236. It means fossil fuel is around 58% of the share, and renewables, including the hydro, it will be around 40% share. Out of the renewables, if you see divided into wind and solar, wind at present around we are 42 gigawatt. It means it's around 10% share out of the renewable, and solar is around 63 gigawatts. It means around 50% share. This is the overview of the present scenario. If you see going forward as a question to answer the question, next 17 years by 2040, what could be the addition for the renewables, in, especially in wind? If you see, I am little conservative side, considering the out of the last few years, in India 2016 I think we had achieved around 5 gigawatt plus. I am considering that is as a benchmark. If you consider the 5 gigawatts going forward, you can able to achieve it. It is going to be add around, you can say 85 to 100 gigawatts you can able to add by 20, means I am considering as a average of 6, maybe initially will be less, later maybe you can say 6, 7 also going to there. If you average it, we can able to add around, as per my personal opinion, we can add max minimum 85 and 100 gigawatts you can able to add. That is what my this one. And if coming to the percentage of share, yes, of course demand is also going to be increased. It is not that only going to be generated, demand also going to be increased. At present 411, its demand also going to be increased. With that, as per my personal feel was, this 10% may go to the 20% on the wind by 2040, what you mentioned, and of course solar may give contribution more because of that cost competitiveness and everything. That may take around can say 25% will be share. That's what as per my opinion, that's what I can do it as a share of the energy mix. Thank you.
Yeah, the same question, Balram.
Good afternoon. My name is Balram Mehta. I work with Renew Power. So whatever opinions are, those are my personal opinions. Company may have different views. I think the wind will have life till the time we don't get an alternate for storage. The moment we get an alternate for storage, the wind's life will be limited. After that, then it will be only like occasional addition. So I think till 2030, wind is secured. Wind, looking into the current construct of RTC, peak power, and the costly storage, wind has a role to play. And like if you see the RTC construct which we have, we are adding 3 times the wind capacity, whatever is the megawatt we have won. So that means wind has a role to play. And looking into our geographies, Karnataka, Maharashtra, Gujarat, each state has different wind regime and wind like resource availability, the time availability, that is giving us some advantage if we plug it all to RTC. So wind has a role to play till 2030, as per me. 2040 is like 17 years away, but till 2030 I think as on date we are there around 40 gigawatt. So I think by 2030 we should be there around 100 gigawatt of wind. That kind of potential we are expecting. So there is a scope of adding more, but then wind has a natural limit of execution, because if you see the today's constraint is only on execution. As far as the sites, there are very good sites available. evacuation I am not counting, I am assuming that evacuation will be available. For execution and going beyond a capacity like 5 gigawatt we did only, like in the last 20 years we did only once. Otherwise, average we are adding 2.5 gigawatt. So I am assuming that if all forces are aligned and if we are able to add 5 gigawatt also, then also maximum we will be able to reach around 100 gigawatt. So that's my best bet.
Yeah, thank you, Balram.
Yeah, good afternoon, everyone. I am Hemkant from LM, and I thank Blue for having me here. And all of us are sorry to stand between you and the lunch, so we'll try to be brief. I think Balram and Prasad have talked about the India perspective, but globally, if you see in the next 20 to 30 years, majority of the new generation capacity addition will be renewable. So as much as between 70% of all new capacity added between now and 2040 would be some form of renewable. And globally, wind would take about anywhere between say 40 to 45% of that 80%. So we are looking at anywhere between 30 to 35% in absolute terms of how much wind would get added. I think there are a couple of tailwinds that you could see in terms of if you specifically talk to India. If you talk about coal retirals, if you talk about higher pace of electrification, then of course the need for electricity will mean that the cheapest source, which is wind and solar together, will actually gain more traction. The second thing is then there are outlier technologies in terms of what else can come in. So kind of white swan technologies that we should leave a small percentage. But having said that, I think the global level, if you take from now until 2040, 2050, you cannot keep wind out of the whole electrification matrix. It will be anywhere between 35–40%.
Yeah, thank you. And Balram, you made an important point that there is a limitation to how far we can go with wind energy. But also there is a possibility that one can look at offshore. And in the offshore, the potential that is assessed by the agency NEWE is around 175 gigawatt you can do in the offshore. The good thing with the current technology in wind is that even on onshore projects, we are getting a plant load factor, I think you all understand, or capacity utilization factor of something like 35 to 40%, you know. That is where the projects become viable, otherwise nobody sets up a project at today's costs and everything. But on the offshore, you can get a higher plant load factor. So you can probably get around 50% plant load factor. And the thermal projects, as you know, they normally operate around 60%, 65% plant load factor. This is very close to what you get from the thermal. So renewable energy, though it is fluctuating and varying all the time, but in terms of the grid requirements, it can provide a lot of power. But I would say, as Balram said and as Prasad said, that for India, we can peg it at something like 100 gigawatt of wind power by 2030, more or less. And then it can increase also. But there is a potential, but we have to see how it will grow, because the offshore government has been talking for a long time now, since last 5–6 years. They have been working on it. They have done the policy. They have done the draft and the documents and things, but one is still awaiting what comes out of it. And what Limaye said is also important, that globally you cannot get the wind out of it because it's a very important component. One major reason is the offshore and the high potential factors that you get from the offshore. So with that, I will move on to some very specific questions to each of the gentlemen. Now, Balram, you have a longish question. You know, so today we have major projects are coming up in the bidding regime and this reverse auction, and through some projects are also set up in C&I. C&I means commercial and industrial segment. Now, your views on power offtake mechanisms, that how it will evolve, what are the tariffs, and whether certain things can happen on the tariff structure, such as, you know, cross subsidy surcharge, open access charges, those kind of things, and how it will, you know, evolve also in the context of this RTC and peak power from wind, those kind of things if you can.
Right. So I think let's divide the question into 2-3 parts. The first question is C&I. Yes, that's an area where everybody is looking into, and because no doubt the bids are there, the options are there, but the kind of competition which we all have with each other, and the bids won by all IPPs, small, big, whatever we want to say. Actually speaking, in today's sense, it's very difficult to make some profit out of it. People have won it, so everybody is executing it. But slowly that is losing attraction. Whereas C&I is picking up because the tariffs are good, and it's a kind of one-to-one interaction. There is nothing kind of the rush of e-bidding and then closing and then declaring, yes, I won it, maybe at a rate which may not be the viable rate. But now the DISCOMs are in trouble, actually speaking, and they are creating all hurdles to stop the cash cows to go out of their kitty, because then whatever is left will be only those subsidized customers, and it will be very difficult to get. I think the viability of DISCOM will be at risk at one point of time, because most of the major customers, they are moving out and having like a one-to-one contract. So there has to be balance between that, and I am sure at one point of time the DISCOMs will take a stand that none of the customers they are allowed to move out to C&I section. Central government is trying, but we are finding issues, and everybody who is there in this sector knows the kind of issues which we are facing in individual states. So that's the point number 2. The SECI auctions are central auctions or state auctions. Slowly, like the people are losing interest in that because of the competition. Transmission infra is the second biggest bottleneck, because Central is working at its own pace, and like few guys are working on transmission infra, whereas on adding the capacity, everybody is working. We are not finding any addition, or if you see in the last 4 or 5 years, not much addition has happened on state utilities. Whereas C&I customer, now the focus has shifted from ISTS to STU, especially in Gujarat, Tamil Nadu, Karnataka, Maharashtra. Whereas STU has not been upgraded, and there is no much addition which has happened in the last 4 or 5 years. This is the point 2. But parallelly, the advantage to wind as on date is that in this C&I, the wind is, the overall share of wind is better than the solar or other components. So from wind point of view, see, it's good that the people are moving to C&I, and we are able to add more wind to the market. But yes, if you see, it's not easy. It's easy to say the IPPs are moving to C&I, but all states, DISCOMs are creating all kinds of issues and trying to stop the cash cows to go out of their kitty.
So good. I mean, one important thing is this C&I. I mean, this is a major market and a major consumer. If we can address that through wind and solar, of course, and as Balram said, wind is a higher component in that, that's a different aspect. But something that is getting in way of that is the DISCOM, and DISCOM is an institution, and the certain regulations which are related to open access, related to cross subsidy surcharge. This cross subsidy surcharge is meant to subsidize those people who cannot pay a higher price for power, say agriculture and all those things. But I have a point here, and I will leave it after leaving that point here. The point is that those who pay a higher tariff for electricity, which includes a cross subsidy component, that tariff acts like a tax, because if there is an industry, for example, there is a pharma industry, they are making some pharmaceutical, they pay a higher price for electricity, then they will pass it on to the consumers. So this is actually a tax which goes back to the consumers, and already people do pay tax. So this is like another tax which comes through cross subsidy surcharge. So there is something which is not correct, or something which is not normal, and something has to be done about it, because this cross subsidy surcharge is not only getting in way of our being able to execute more projects for C&I kind of customers or maybe similar other customers, but also that it is something wrong economically, from an economic perspective for the whole country. So I think, I don't know if there are, generally in such audiences, I see very few people who are from DISCOMs, GETCO or 10 GETCO or something. So we don't get their views normally, but
No,
that
but
is a point.
here, if we see it from DISCOM point of view, they are also running an organization like we are running, and they also have to show the performance. But if they are left with all kind of, because we know, every Indian knows the kind of political topic which especially the electricity prices and increase or decrease in the electricity prices is concerned. So they are also in a flux that what to do, because they have to fulfill the commitment, they have to run the institution which is a kind of not profit making, but at least no loss, no profit making institution. So I am sure, I think they are also right in ensuring that at least the customer who are paying paying more than their procurement price. They are able to serve that. Otherwise, if those guys go out, then and they are procuring power at 4 rupees and selling at 2 rupees, then it's better not to supply. So they are also in a flux, I think so.
Yeah, but there may be solutions to that, and this is something that government can do through some policy mechanism or giving direct subsidies, instead of giving the subsidy through electricity pricing. So there can be those kind of solutions. Then I have some question for Mr. R.P.V. Prasad. Prasad, he looks after the manufacturing and of a wind turbine, and so where do you see the technological evolution going? You have come up with a wind turbine which is around 3 megawatt plus in the market, and what will be the size of wind turbine in say 10 years from now? And you see, this is something, there has been a trend that the wind turbine sizes have been increasing over a period of time. What do you?
Yeah, exactly. See, technology evaluation is must. Of course, it is a continuous process. Everyone knows that it is a continuous process. And we already witnessed in India from last 2.5 decades. We saw that, even myself is started in wind career from 95, 96. We started from 200 kilowatts to now we are in 5 megawatt already there in India, right? And in terms of not only capacity, and in terms of increasing the rotor, I think earlier we used to know that only 30 meters of rotor dia. Now we are talking about 150 meters of rotor dia. And even hub heights also, earlier I used to know that 50 meters, 40 meters. Now we are talking about 140 meters. So that's what these are the technology evolution is must, and we have to be continuously do it. And coming to the your question on the going forward next 10 years, how it will be. See, if you see in globally at present, we have almost you can say 6.5 to 7 megawatt of wind turbines are available globally. In India, we already there is 5 megawatts, but we have a lot of other challenges. Not only developing the new turbines, and we have our own challenges as a country. We have our own challenges. For example, logistics. For example, we want to be launched as an Envision. We want to launch as a next model. For example, just I can say 182 of rotor. We done the survey of across logistics. Yes, our highways can take care of this rotor of 182 meters of rotor, but we are facing a lot of challenges from the highway to the taking to the interior. You know that interior sides of this one. At present, luckily, we have at presently 156 meters rotor there. That is, we have succeeded. We are already delivered to the project sites. Going forward, these are the different challenges are there. Considering all these challenges, maybe I don't think this megawatt will be increased drastically on the capacity wise. Of course, still I believe it will be going to end up with next 10 years, just 10 years. It will go to the between around 7 to 8 gigawatt may launch in India. That's what my gut feel. And coming to the not only technology, you are talking about technology evaluation. Technology evaluation not only just simply you can say like a, of course these are the internal things we can develop. Otherwise, we have to see considering demands of the customer, like I mentioned that around the clock. So as a from wind side also we have to evaluate, like customers wants better performance of the turbine. So we have to see that how we can able to manufacture that, how we can able to design the better profile of the rotor, so blades. At the same time, longer life cycle. Customers are asking for longer life cycle. How we can longer life cycle of the turbines are required. So these are the different things technology evaluation is adding, and cost effective. That is one of the more important cost effective, because as you all know, solar is one of the cost effective. We have to compete with that. So we have to see that wind also, how we can be cost effective turbines we can launch it. And nowadays, it's one more thing. These are the not only things, how smart our turbines are. How we can use the, we know that now digital is like artificial intelligence. How we can use the data, available data into the inbuilt into the design. How this artificial intelligence, how it smartly turbines will be response during the next, not only for the design period and going forward in operation time also. How we can able to smartly manage the turbines. These are the things is going to be evolved in the technology. So these are the of course challenges for the OEMs for the to deliver the best turbine to the customers. And of course, one more thing you can say, we know that wind regime, we have to consider wind is one thing we have to see. Now class 1 winds are not available, that's the reason we are talking about repowering, and class 2 we are talking about class 3 wind sites. So even that is also one of the challenge. With the going forward, it may be further reduce the availability of the windy sites, but still we have to see the how we can able to perform the turbines better by increasing rotor or maybe by seeing the different technologies, how can able to inbuild that. So these are the challenges. Of course, our R&D teams are putting all the efforts just now as mentioned, and we are delivering the best technology turbines to the in India.
So in essence, you are saying the size of the wind turbine may not increase drastically.
Like earlier.
Yeah.
Like earlier. Yeah.
But there will be modifications and there will be approaches and methods within the turbine how to make it run better and more efficiently. Before I come to Limaye, Balram, there is a related question because you are running a very large fleet of wind turbines. What is your view on use of some advanced methods of operation and maintenance, like artificial intelligence or I would say big data or data analytics? How that is helping you in improving the performance?
So I will take 30 seconds to comment on technology. If you see the, like I am there in wind sector for the last 21 years, I think, younger than most of you guys have better years. Not much has happened as far as wind technology. It's like we are increasing the rotor diameter and increasing the height. Whereas as far as material is concerned, not much improvement. Better control, yes. If you see 2003 turbine and 2023 turbine, controls are better. But there is no like quantum change like the way it has happened in solar, I should say. But yes, only one thing that has changed is the better sweating of turbines. That has improved a lot because in 2003 when I started, nobody was worried. For for the next 7-8 years, if turbine was generating, whether it's generating optimally or not, nobody was bothered. But now, because of the IPPs coming in picture, this perception has totally changed because performance and sweating of assets is our bread and butter now. Practically we have seen, like earlier everybody was managing it on DGR report, whatever we were getting from OEMs or from some Excel sheets. And now, like for example, if I take the case of Renew, we have around 2,000 turbines. And 2,000 turbine analysis, somebody wants to do on Excel sheet, it will take like by the time the wind season will be over, that the first cycle will. So we have to go for digitalization that automatically. I will give my experience. We tried it with some solutions available in the market, then we tried to have our own system, and like unofficially I am informing that we found a performance delta of around 100 crores. Like 100 crore, we didn't know that we are losing it because of the non-performance of wind and solar assets. At zero investment, it's only the system is telling that, okay, this turbine is not performing, or this particular set of modules is not performing, and we are working on it. So that has helped us a lot, frankly speaking. And now we had made it like the complete, around 20-25 guys are only working on it, because by spending like 2-3 crores, if we are able to save 100 crores. So digital has to be part of the system now. We can't live without that because the quantum has increased a lot.
Yeah, I mean 100 crore is a very huge amount, and I would say this is the sort of power of analysis, the power of analysis that we often miss out. We invest in equities, we invest in asset, then we invest in a team, in the organization, we get lending, but we sometimes do not invest so much in analysis, and this is.
And sorry, change in perception also, because when we started this journey, I was the guy who said to the team that what will these youngsters or the 2-3 data scientists, data engineers, they will tell us, because we are operating, maintaining machines for the last 20 years. We know it's optimal performance. So it's like changing the mindset also, and then like accepting, yes, we are not running effectively and efficiently.
By the way, I would like to mention that Balram was earlier with Enercon, no? Yeah. So he is ex-Enercon, which is a manufacturing, wind turbine manufacturing company, one of the leading wind turbine and technology companies of its time. And Prasad is also ex-Enercon, and I am also ex-Enercon, except Limaye perhaps.
And there are many guys sitting in the audience also.
Who are probably, yes. Yeah.
And just adding to Balram, not only this performance, this data is really useful for the analyze. Of course, I mean to say, going forward, the design the new turbines, how we can, as you rightly mentioned, now 100 crores is benefits if you do the continuous performance monitoring of 24 hours, 24/7. So this data can be used for our R&D teams. Those can be, instead of these inputs will be very valid. So those inputs taken to the design also. Maybe we can see that how we can able to reduce that performance, easy for the O&M operation next level. That is also very useful, this data. So that's the reason this data, digital and artificial intelligence is must inbuilt for the.
Yeah, as Balram said, that this is the end of Excel sheets. This cannot be done on Excel sheets. Correct. And the thing is that the data that comes from the wind turbines is SCADA data, and there are hundreds of parameters in it. So if the performance of a wind turbine is not as per expected, it is very difficult to just straight away find out why it is performing lower, unless you deploy some very heavy data analytics approach to figure out how different parameters are correlated with different performance parameters. So that is there. Limaye, you have been into blade manufacturing for a very long time, and the blades also have changed in size and different ways over a period of time. And one aspect of wind energy which is the key to its development, or rather a barrier to it, is the logistics of transportation, and also logistics of setting up blades and assembling it and setting it up on the wind turbine. So your views on how this can improve, anything on the technology front, anything on any other technical or logistic front that that has to do with blades basically, because ultimately this is the blades which become difficult to transport.
Yeah, but before we go there, I think a couple of things on the blade side and on the technology toolbox. I think essence is that rotor is the motor. Efficient rotor means efficient turbines. If the rotor is not efficient, you can have a fantastic technology on tower. It will mean nothing to what we call it as AEP, or the annual energy production. And that is where the fundamentals of physics come into the picture. I think the larger swept area has a significantly higher influence on the AEP as compared to just increasing hub height, and also the nameplate. So these three need to go hand in hand. But if you compare between the three, increasing the rotor size is probably the highest ROI on AEP. And that is where a lot has happened over the last 20 years. Not only in terms of how we look at the length alone, but there are three other aspects that we should take into consideration. One is higher AEP means higher loads. So it's a simple correlation. It also means that you cannot if you have to increase the blade length, you need to be able to do it while controlling the loads to be more efficient. So the technology toolbox that was available 20 years ago and what is available today has transformed phenomenally. To do this, you need a very nuanced knowledge of loads. I have.
No, no, you use this.
So very nuanced knowledge of loads, aerodynamics and controls, and that is where this triology is kind of coming together, because one alone is not going to take you to the next level of performance. So this is where the technology toolbox has improved a lot in terms of the tools that are available, the CFD, the FEM, the kind of analysis that we do today is very, very crucial. The longer the blade, I think the problems are more. So essentially, to go a little bit technical, you are moving away from load-based design to a deflection-based design. And longer the rotor, the deflection is more pronounced, and there are different type of issues that we will face in terms of how does a very, very long blade, a very slender blade actually works on a real life turbine, and how can you simulate that with a digital twin and marry it with the turbine to offer the best outcome. The best outcome could also mean that you sacrifice a little bit here and there, but keep vibrations under control, keep a long-term life of the system under control. So this is where the case for a longer rotor, a more efficient or a more advanced rotor finds value. Of course, it will come with a lot of challenges, and I think Prasad has already mentioned about logistics, but it will also mean improvement or upgradation of cranes that will be required to erect that kind of longer and heavier blades. And then also the question I almost get asked is, then do we go to segmented blades? Segmented blades, we have proved that it is feasible, but honestly, you cannot have one size fits all. Just because you have a segmented technology available, you cannot put it everywhere. The segmented technology comes with a price on, of course, it comes with a challenge on price, but it also comes with a penalty on the turbine design. As long as the end result in terms of a levelized cost of energy and in many cases a viability of project itself, then of course segmented technology is available, and you will see that projects where if you had a choice between, okay, should I do a 3 megawatt 120 rotor versus a 5 megawatt 170 rotor, then of course the segmented technology pays for itself. It will not be a one size fits all. So overall, I think there are tools available, and the technology will keep pace with what the market demands.
Yeah. Good. I think you pointed out about segmented blades. I was thinking, but I thought maybe it is too far-fetched a thing. But how do you segment? Means you have blade in pieces and then you put them together? What is the meaning of this segment?
Yeah, means for now it is in two sections, and then there are multiple ways of assembling it on site.
On site. So you have smaller pieces that go there. That
no, two pieces.
Two pieces at the moment. Yeah, yeah. That's a good thing. And
you mean already available any across means outside India, is anything done? Oh, good. Yes. Interesting.
Yeah. So we discussed something on about the offtake arrangement and things like that, and we are mostly discussing onshore projects, though offshore have been in the sort of on the table for a long time. So Balram, I mean, as a IPP, as a very large IPP, obviously you have looked at offshore possibilities also, and maybe if and when there are the tenders or things open up, you will participate. So your views on how much we can do in offshore, what would happen over the next 10, 20 years. My understanding was that to do a first project, you need at least 5, 6 years of time as a gestation period for an offshore project. So if today we are in 23, before 28, and there could be delays, so before 2030 we may not have any offshore wind farm project at all. But your views on that?
No, perfectly said. I think it's a kind of start-stop kind of a thing which is happening as far as offshore, Indian offshore is concerned. We had a very good start around 3 years back, I think 3.5 years back. Good consortium, good discussion happened, and we went ahead, everybody went ahead. But then suddenly there was a stop. And now again it has started with the different options, whether you want to sell it in the market, that option is available, you want to sell it to SECI, that option is available. But actually speaking, there are many issues which are still unanswered, especially the kind of contribution which Government of India has to make on creating the infra, whether substation onshore or offshore they will give, what kind of VGF, what kind of facilities, because that will decide finally what will be the tariff. But the basic question remains that it will not be a cheaper power, that everybody knows. Now the question is, if it is not a cheaper power, then DISCOM already we discussed, like good customer will move out, they will be left with subsidies, and then whether they will be able to survive or not. So there has to be like a holistic approach which somebody has to look into as far as the costing is concerned. As far as the execution is concerned, I think frankly speaking in India we don't have that kind of expertise, and actually speaking many IPP developers, we don't know what is the kind of cost involved in it. And we have to depend on our foreign partners, and it's good. There is no logic of inventing the wheel if wheel is already there. But foreign investors, including the OEMs, they are also a little bit confused. It's a kind of chicken egg story. They are looking. They will set up the facility if they are able to find a good IPP, and good IPP is looking for the cost from them. So we have to tell them the volume, they will give the cost. We are not able to give the volume because we don't know what is the cost. Like I think the work has to be done on it. But as far as Government of India is concerned, I think they are fully committed. And from the longer perspective, we see from energy security point of view, we have to go to onshore. There is no second thought on that. How can we like speed it up? That's a question mark. Everybody is working on it, and I think many European countries are helping MNRE, MOP to come out with a practical document. If you ask me how many megawatts, I think my conservative estimate is that like 3 to 5 gigawatt should be on sea by 2030. And once it starts, and like we are able to have the associated infra developed around it, we need to have that kind of skill level, skilled employees who can handle that. I think then it will be very fast. But then the first megawatt is difficult.
So this,
adding to what Balram has mentioned, I will share my experience on offshore. So recently we done, you know that prototype and test type Limaye is trying to do it. We involve and we do some survey on the logistics, million logistics, how these huge equipments, how we can able to transport to this respective location. Now we know Gujarat and Tamil Nadu, these two are the main area. Is it? Thank you. Yeah, just we done a just study on that, how we can able to transport these huge heavyweight nacelle, hub and blades. We done study because initially we know that day one we cannot able to manufacture in India. We have to definitely import from outside India. So we saw that maybe we studied in Tamil Nadu. So from Tuticorin materials will come to Tuticorin, and from there how we can bring through sea waters, how we can able to bring to the Dhanushkodi. That's what we done some study. It's entirely different, interesting survey. They required a lot of marine engineers got involved into that. How the barge can be designed to for that, taking the blades into the respective location. So with this, what I'm trying to say, maybe the scenario, it is going to be changed on the logistics and at this point of view. Maybe we have to see that logistics may not be possible in by road. It will be definitely we have to use our sea route to bring the materials to the this one. And of course, considering the volume and I think initially maybe it's the minimum required around 8 megawatt is required. I think that's what we done some study on that. At least to launch, at least 8 megawatt is required. That's what we done. With that 8 gigawatts means you know that how much it will increase. Now presently 5 megawatt and 3 gigawatt itself, 3 megawatt itself, we are having a lot of challenges and the logistics everything. So these are the different challenges will open. And of course, we have one challenge is there. We have to find the solution. We definitely, I'll see that as Balram mentioned, government is very positive. They are coming up with the lot of, at present challenge is price. As you mentioned, price is the challenge compared to cost per kilowatt hour. How much, what is it? Now it is not viable. If you put it whatever calculation do, it will not viable. How government is coming up with a good supporting? Yes, they are coming with the VGF fund, something it is coming. So that's why we have to, I think future it will see that. Thank you.
So as you see this chicken and egg situation, and typically all IPPs or investors, they would like to minimize their risks and get returns in a reasonable period of time. But today we are seeing that the kind of tenders that are on table is that you are assigned certain blocks in the sea, and you will do your assessment of that and come up with a DPR and all that, which will take about 5 years. So the point is to make an investment today for some outcome which will be a project maybe 5 years later, and then the project will pay back in 25 years. So this is a very long drawn out thing which many people used to investing over 2-3 years and setting up the project and getting the returns may find it difficult. So one thing that comes to my mind is that when we started wind energy in India, there were no wind projects at that time. The government set up some demonstration projects. So they were small projects, roughly something like 2 megawatt in Kayathar and like that. And then Danida came in and they set up 2 large projects, one in Gujarat and 2 in Tamil Nadu. They set up large projects to demonstrate that how it works and whether it will be beneficial for the industry and other players, investors to come in. And that was the beginning because it created the right kind of ecosystem. So in offshore also we need a different kind of ecosystem. You have ships, you have jack ships, you have transportation, a different kind of hubs. So all these things are very different which do not exist today in the country. So one possible idea or a recommendation could be that the government sets up some demonstration projects, maybe 500 megawatt or something, and this will create the right kind of ecosystem and experience to move forward. So that was on the offshore front. And then we have already discussed a lot on logistics and infrastructure challenges. And one thing which still remains, because we have got something like 42 gigawatt of wind power in India, and in future it will continue to increase. So we have many wind turbines which have to be scrapped, which have become 30-year-old or 40-year-old. So what happens to the rotor blades, which are scrapped, and is there a recycling issue which is also connected with refurbishing? And suppose we have old wind turbines, we can refurbish them, use it in some manner. So repowering, refurbishing and recycling, these are related issues. So I will ask Limaye because he is the blade guy. So that is from the recycling point of view, what are the options and how we can look at recycling rotor blades?
Thanks, Jami. I think this is what is the need of the hour. I would largely put this in 3 buckets. One is what do we do with decommissioned blades? So that is a decommissioned turbine. So even today about 90% of a decommissioned turbine is fully recyclable. The metal part is easy. What you are left with concrete, and then you have composite. On composite, we are part of many global study and consortium projects. DECOM projects is one of that. It talks about reuse and repurpose on decommissioned blades. Repurpose is kind of non-industrial scale. It is recreational, I would say. So you see many times that a chair is made out of a recycled blade, or a vehicle shed, or a cycle stand, but those are at recreational level. It is not at an industrial level. On industrial level, the technologies are evolving. The biggest reuse is, we have seen taking the blade and using it as a filler in cement or such applications. So you take the blade, you take out the metal which is at the root, and then you shred it, or you use certain processes to use it in cement. LM, which is part of GE, we have worked on couple of projects. There is a end use in North America, in Veolia. With Veolia, we already have a contract which will recycle the LMGE blades and use it as with cement. Similar in Europe, we have done with Holcim Lafarge. So there is repurpose scheme, but now it is kind of, it has to industrialize and it come at a cost where instead of sending it to a landfill, you are able to repurpose. In terms of legislation, Europe is ahead again, and they have actually put a formal ban on landfilling, which industry is accepting for Europe. So by 2025, there will not be any landfill. The third is about recyclability, and recyclability is really at the design stage, and there a lot of work is happening. I think if you search the net, we are demonstrated a fairly large blade, 60 plus meter blade with recyclable resin, meaning that once the blade is done with its life, you are able to recycle the composite part of it. I think the other large players are also saying the same, but that is for future. For now, I think there are, it's up to the two things. One, as you said, extend the life. So what you could do now, you don't have to do it now. You will have to do it 5-10 years later. So extend the life and then use one of these industrial grade recycling possibilities to avoid any landfill.
Good. And Balram, you will have something to say. You can also touch upon repowering, which we have not discussed so much.
I think the government has come out with, the MNRE has come out with a repowering policy, but it's not taking, like giving that kind of traction which it should have. And especially we Indians are too much obsessed. My father was driving Ambassador. It was not running. We were putting hot water before starting. Like most of the time it was in workshop, but he was not ready to part with the vehicle. So we are obsessed with it until the time it is running, whether it is running effectively, efficiently or not, we are somehow running it. And the same is happening in Tamil Nadu, because like even if it's generating, because all debt is paid, so even if it's generating 1-2 lakhs of revenue, the people are just running it, one. And the second is, like we are discussing the kind of transmission infra which we need to upgrade. Immediately that is not the requirement. The equivalent kilowatt or megawatt we can replace with equivalent kilowatt megawatt, but with the better PLF, so the generation will be better. With the same megawatt, we can have better green units from the system. So somebody need to work on it, but who will work? That's a question mark. Because we IPPs, we are busy in like adding the new capacity, new projects. OEM is busy in giving the new machines, but the kind of effort it needs, because individual machine, like going to the individual customer, having some kind of settlement, and then buying one, two machines, making it a group of machines, then decommissioning, that will take time. But I am sure looking into the kind of wind potential whatever is available in those states like Tamil Nadu, Karnataka, Maharashtra, if one team comes out with a specific target of like gathering those machines and then working on some mechanism, I think this can be a good business proposition.
Yes, as rightly mentioned. And see, now these are the repowering sites available more of a class 1. So at present in India, class 1 turbines are not available. Of course, we are more into move to the class 3 and this one. So that is again, as Balram mentioned, we are going also be think over how to be see its average wind speeds is around 7.5, 8 above 8. That's class 1 in Tamil Nadu and Gujarat mainly. So we also to be think as a OEM to think the how can able to fit for this class 1 sites. That is one thing again, one more. It's not a challenge, of course, can bring the class 1 turbine. It will take time. And then again, land parcels is a lot of piece of each means you can say 10 acres means maybe 50 owners will be there. So that is also one challenge. Maybe how we can able to see that bring to the table and give repowering to be done. Of course, for that also government is really pushing and trying hard for the doing that. For intention was to add the more to achieve our target, country's target. So that is also one of the way to complete our target on it.
Yeah, I think repowering, the one major problem is that those who have those old wind turbines, they are not too eager or too keen to do away with it. They are getting a few lakh rupees of revenue and they are happy. They are happy with it. And so one possible way to look at it, and then there are technological issues because those sites, those wind turbines are not being made currently, is that a financial institution say agrees to finance 100% of a repowered project or maybe 90%. The reason for that is that those projects have no risks. The wind resource is well proven and one can see that track record over last 30-40 years. So they have no risk. They can just finance a new project so that the old owner doesn't have to bring in any financial resources afresh. And from the same generation, he can pay back and as well as get some same revenue as he was getting. That could be a possible solution. But of course, there are issues of power evacuation, of land and all those things. It's a complex thing. So that's why it is not taken off so much. We hope it does take off. With that, more or less, we have what we thought was reasonable to discuss in terms of propelling wind forward, or rather wind propelling the nation forward. So I think we are all adequately addressed with this aspect. If there are any questions any of you have, you are welcome.
I am from Garuda Aerospace, Chennai. I just want to understand from you, how do you visualize that drones can bring more efficiency in fast visual inspection of wind turbine blades in India?
Balram, drones.
Yeah, I think in blade inspections, and we have already started using it, and we have gone one step ahead of it. That one is the pictures, and then physically analyzing it, manually analyzing it. We have made an algorithm. So like drone sends the pictures, and system does the analysis, and then we get the results. So drone is playing a good role as far as performance improvement is concerned in wind as well as in solar. And we also try to do experiment, but it's like well established on transmission line also. That has also given very, very good results. So drone has a role to play in wind, no doubt on that.
Thank you very much, sir, for your valuable feedback.
Good afternoon, I am Deepak from Zebra. My question is related to reliability of gearboxes, conditioning, monitoring of gearboxes. Are we doing something on that?
Gearbox.
So there are standard solutions available as far as gearbox like condition-based monitoring is concerned. But like when everybody is looking for some cost reduction somewhere, including IPPs and OEMs, so like in most machines it's not available. But now since we have realized the value of that, like even in the old machines where the CBM is not available, we are putting it up. And now I think we, like even in purchase we are making it mandatory that all these kinds of condition-based monitoring systems wherever is possible, and that has a major role to play, no doubt on that.
See, considering the compared to earlier now, the sensors are increased to do the condition monitoring. For example, what we supplying the now presently compared to earlier now, this number of sensors in the gearbox wherever the condition monitoring are key areas are required. So the sensors are increasing, so that will be helpful for the pulling the data to closely monitor the what is happening. It's more of a predictive. If you see these sensors, what we're going to do is give the throw the data. You will not wait for the breakdown. Maybe it will give the throw the data so that it can see the predictive maintenance. We can do it before anything goes wrong. We can came to know before itself, so that we can act on in advance.
So it has added a huge value, no doubt, and yeah. So like sensors and condition-based monitoring system, and wherever we can put sensors. So now the people are keep like payback period is, I think, just one breakdown, and you get the value for the next 20-25 years.
Any other question? So I would like to thank Mr. Limaye, Balram and Prasad for giving their inputs into this panel discussion. Thank you everybody.
Thanks to you all.
Thanks to you.
And we have been keeping you away from lunch, so my apologies.